Bismillahirrahmanirrahim. Still we are speaking about the logarithmic functions. And we define the logarithmic function as f of x equal to log with base b of x, where b, the base is none or is greater than 0 and not equal to 1, where x must be a positive number. And the domain for the logarithmic function is from 0 to infinity if it is with log x base b. And we mentioned the basic properties for the logarithm and gave some examples how to evaluate the logarithm and also how to convert from logarithmic form to exponential form or from exponential form to logarithmic form. In this part, we are going to speak about graphing the logarithmic function. We'll start with the graph or sketching the logarithmic function. Start with the basic example that we need to graph the function y equal to log x with base 2. The best and easiest way to graph this one is to convert the logarithmic form into exponential form. So I'm going to convert this function from the logarithmic form to exponential form. This is equal to and if x equal to power y. So now I'm going to graph this function x equal to 2 to power y, or using the exponential form to graph the logarithmic function. Now for x equal to 2 to power y, as we did in the last section, graphing the exponential function, but in this time, my independent variable is y, and my dependent variable is x. In this form, it is x equal to 2 to power y. So to graph this one, I'm going to use y to be my independent variable. I have x and y. As usual, we are going to choose 5 points. But in this one, I'm going to choose y. -2, -1, 0, 1, and 2. And then find the values of x. Now, if y equal to -2, let's find the first one. If y equal to -2, then x is equal to 2 to power -2, which is equal to 1 over 4. So x equal to 1 over 4. Now, the second point, if y equal to -1, then x will be 2 to power -1. That will give me 1 over 2. If y equal to 0, then x equal to if y equal to 0, then x will be 2 to power 0, which is equal to 1. This is 1. And if y equal to 1, I will have x equal to 2. And if y equal to 2, then x equal to 4. Now to graph this one, to graph it, this is x and this is y. And the points are, first one is 1/4 and -2. This is, let's say, -1, -2. Y is -2 and 0 we have. Then we have 1 and 2. X start with 1/4 and -2 to this point. Second one is 1/2. Say this is 1 and -1. Third one is 1 and 0. Then we have 2 and It should be 4 there. 2 and 1. This is 2 and 1, and then we have 4 and 2. So the graph is taking this curve. This is the function x equal to 2y, or we can say it is y equal to log 2 of x. As we mentioned before, the exponential function is the inverse of the exponential function. The logarithmic function is the inverse of exponential function. And as we said before, if we graph the function and its inverse, we will see they will be reflected around the y equal to x. If we take the reflection of this one, let me just use scalar, I will have this function is y equal to 2 power x. Y equal to 2 power x is the inverse of y equal to log x with base 2. And since they are inverses, we'll see they are symmetric around the line y equal to x. Let's take another example. It's a graph, this example. Y equal to log of x minus 1. Now log of x minus 1 with base 2. Before graphing this one, let's find the domain. To find the domain, we said that we have to say that x minus 1 is greater than 0 to this part must be greater than 0, which means x will be greater than 1. So the domain will equal to 1 to infinity. So the domain for this function is equal to from 1 to plus infinity. Now let's graph this and see why do we need to find the domain and what's the meaning of that distance from 1 to infinity. Now to graph this function, again, I'm going to write it in the exponential form. I have x minus 1 equal to 2 to power y, or this will give me x equal to, move this to the other side, it will be 2 to power y plus 1 equal to 2 power y plus 1. Now find x and y, or graph these points. Let's find x and y, using y as independent variable. This will be enough. 5 points will be enough. It's smaller there. So now my independent variable is y. So I'm going to choose y first. So it is minus 2, minus 1, 0, 1, and 2. Now if x equal to minus 2, or if y equal to minus 2, if y equal to minus 2, then x will be 2 to power minus 2 plus 1. That will be 1 over 4 plus 1, which is equal to 1/4, or 5 over 4. So this is 1/4. Now if y equal to -1, then x equal to 2 to the power -1 plus 1. That will be 1/2 plus 1, which is equal to 1/2. If y equal to 0, then x will be 2 to the power 0 plus 1, which is equal to 1 plus 1. That will be 2. If y equal to 1, it will be 2 to the power 1 plus 1. I will have a 3, and if it is 2, I will get 5. Now the graph for this function is x, and this is y. Now we see the domain there. We say that d or x is greater than 1. What does this mean? X greater than 1, it means that we are going to have at x equal to 1 something called the vertical asymptote. When x equal to 1, this is 1, I have vertical line. So the graph of the function will not intersect with this one. I will call this the vertical asymptote. It is x equal to 1. Now, if we start analyzing this point, I will have the first one is 1/4 and -2. It will be down. This is 1. This is -1, -2, 1 and 2. So the first point start with this. Second point will be 1/2 and -1. Third point is 2 and 0. This is 2 and 0. Then we have 2 and 3. This is 2 and there. 3 and 1. So this is 3. This is 2. 3 and 1. And then we have 5 and 2. So the graph for this function now will be so this is the graph of y equal to log base 2 of x minus 1. And you can see if we compare between this one and the above one. This is the red one. It is log of x with base 2, and this is log of x minus 1, which means that the graph is shifted 1 unit to the right. And we have vertical asymptote x equal to 1. We have y-intercept. Sorry, not y, this is x-intercept. X-intercept equal to it is at x equal to 2. Or I can say it is at the point 2 and 0. This one. This one. This is the x-intercept. And one more thing, that the base b equal to 2, which means the function is increasing. So we have the function is increasing, and we have vertical asymptote that x equal to 1, and we have the intercept of the function. It is in the at the end on the x-axis, not on the y-axis. For the exponential function, we have y-intercept, but for the logarithmic function, we have x-intercept, and that's why when y equal to 0, I will have the value of x, and you can see the values of x start from this point, x equal to 1 going to infinity. This is the domain of this function. So this is how to find or how to sketch a logarithmic function. Convert it to exponential form, use y as independent variable, find x, then sketch the graph of the function.